In this section, we will talk about the graphs and the lines in the plane. So the first thing we want to introduce is the Cartesian coordinate system. The Cartesian coordinate system is used to locate the point in the plane. What is the position of this point, right? And the Cartesian coordinate system consists of two things. The horizontal line, which is called the x-axis, this is the x-axis, and the vertical line is called the y-axis. Okay, so here this point is called the x equals 0 and y equals 0, which is called the origin. Okay, and this is the origin. And if you have a point here, what is the position of this point? This point is given by which is called coordinates. So here, if you draw a vertical line, intersect x at this point, if this is the value a, if you draw a horizontal line which is vertical to the y-axis and intersect y-axis at this point, this would be the y equals b. So we can use this a and b to locate this point p, and we can write this one p as parentheses a, comma b, and this is called coordinates of this point. This is called coordinate. And the first one is called x coordinate. And the second one is called y coordinate. Okay? And then you can use this x, y coordinates to locate this point P. And the origin has a coordinate which is called 0, 0 coordinate. 0, 0 coordinate. Okay? And that means x equals 0 and y equals 0. So here, in this part, this is called the first quadrant. In this part, all the points has the positive and the positive x-axis coordinate and the positive y coordinate. So this part is called first quadrant, and this part is called the second quadrant, and here is called the third quadrant, and this is called the fourth quadrant. Okay? So now we want to look at the graph for the linear equation in two variables. So the linear equation in two variables is given by this kind of form, which is a times x plus b times y equals c. Okay, so you can see this a, x, and y has the degree 1. There is no product between x and y. Okay, we only have some constant a multiplied by x and some constant b multiplied by y. So this is called the linear equation in two variables, x and y. So it will represent a line which is a straight line. Straight line. Sometimes we just call line. A straight line in the plane. Okay, so this is our x. This is the straight line. Okay, it could be in this one, it could be this one, right? It could be other lines. Okay, so now we want to know how to draw the line in the plane. So if you have an equation in two variables which is given by this form, this is called the standard form of the straight line, standard form. So how to draw the equation, or how to draw the equation in two variables, linear equation in two variables. So before that, let's look at what is called the x-intercept and the y-intercept. Okay, so you can see that if this line intersects y-axis at this point, and this point is called y-intercept. If this line intersects x-axis at this point is called x-intercept. So for y-intercept here, the x-coordinate for this point is always 0, right? This is 0. So the x equals 0. And for the x-intercept here, the y-coordinate for this point is also 0. So this one gives you a way to find the x-intercept and the y-intercept. So how to find the x-intercept and y-intercept? So to find the x-intercept, we just need to set y to be 0, then solve the equation. Solve the equation, the linear equation for x. Then you can find x-intercept. Then the y-intercept is you set x to be 0, because the y-intercept has always x to be 0, right? Then solve the equation for y. Then you will get y-intercept. And then we know if you have 2 points for a straight line, you just connect these 2 points, you will form a line, right? So this is the way to graph a straight line. You need to use 2 points, locate 2 points, then you connect these 2 points, you will have a straight line. There is many ways to locate arbitrary two points. We have many points on the line, right? You can locate arbitrary 2 points on the line. And one quick way is to locate the x-intercept and y-intercept. Of course, it depends on the problem. Sometimes you locate other points would be more convenient. So now let's look at some examples. The first example, y equals x minus 5. Okay, so for this example, we want to use the x-intercept and the y-intercept. So let's look at the x-intercept. How to find the x-intercept? You set y to be 0, right? Set y to be 0 in this equation. So this is called 0 equals x minus 5. So it gives you that x equals what? 5. Right. So the x-intercept would be x coordinate first, then y coordinate, 5, 0 point. Then y-intercept, you set x to be 0 in this equation. So y equals 0 minus 5. So it gives you that y equals negative 5. Right. So 0, negative 5 would be the y-intercept. So now let's draw the graph. You locate x-intercept 5, 0. So this is the 0. 1, 2, 3, 4, 5. This is 5, 0. So this is this point. And another one. X equals 0. Y equals negative 5. So negative 5 is go below x-axis. 1, negative 1, negative 2, 3, 4, 5, negative 5. So this would be this point. Then let's connect these 2 points, use a straight line. So this is the sketch of this graph. So another one. Of course, you don't need to have to find x-intercept and y-intercept. You can find the other point, right? You just need 2 points. Remember, you just need 2 points to satisfy this equation. If the point is on the line, it should satisfy this equation, right? So you just need two points to find 2 points to locate these 2 points, then connect these 2 points to get this equation and this line. Another example is 2x minus 5y equals 2. Okay. So here, one way, we still want to find x-intercept. So for find x-intercept, we need to set what to be 0? Y to be 0, right? So if you plug in y equals 0, so it becomes 2x minus 5 times 0 equals 20. So this would be 2x equals 20. So x equals 10, right? X equals 10. And if y-intercept, so x equals 0. So 2 times 0 minus 5 times y equals 20. So this tells you that negative 5y equals 20. Then divided by negative 5, you have y equals negative 4. Right? So the x-intercept would be 10, 0, and negative 4. This would be y-intercept would be 0, negative 4. Okay? So you can locate these 2 points to draw the graph. Of course, we can use another one. We can just choose, for example, we can choose x equals, we can choose other point. Okay, we can choose another point. If we set x equals, we just set any number you want for our convenient, right? 5. We set x equals 5. So this would be 2 times 5 equals minus 5y equals 20. So this would be 10 minus 5y equals 20. We subtract 10 on both sides. So you have negative 5y equals 10. So y equals what? Negative 2. So in other words, this point should be also on the line, which is 5, negative 2. Okay? So we can pick arbitrary 2 points. Right? Actually, we find 3 points on the line. So we just pick arbitrary 2 points. For example, we pick these 2 points, right? Negative 4, 0, negative 4, and 5, negative 2 to draw the graph. So this would be 1, 2, 3, 4, 5. 5, negative 2. 1, 2. So this is here, negative 2. So this is 1 point. Another point is 0, negative 4. 0, negative 4. Negative 3, negative 4, negative 4. So this is another point, right? Then we can connect these 2 points. Right. There you have this straight line. It's not necessary to be the x-intercept and y-intercept. Sometimes we can choose a point which is more convenient for you. So now let's look at another one, which is the y equals 5. Okay, y equals 5. What does this mean? The y equals 5, which means no matter x value is, y always 5. So this is 5, right? 1, 2, 3, 4, 5. This is 5. No matter what x value is, x equals 0, it's equals 5. X equals 1 equals 5. X equals 2 is also 5, right? So which represent a horizontal line. If y equals a constant, which is a horizontal line. Okay. Another one is x equals 3. X equals 3. So that means no matter what y value is, it always be 3x, right? So when y equals 0, this is 1, 2, 3. X equals 3. When y equals to 1, x equals 3. When y equals 2, it's also 3, right? No matter what y value is, it's always 3. So you connect these points, which will form a vertical line. So if x equals a constant, it gives you a vertical line.